Hi, welcome to Sahadhyayana. We are on a video series on embedded systems, and in the previous video we have seen what is an embedded system and how it can be distinguished from a general computing system. In this video we are going to check out what are the characteristics of an embedded system. We know that no matter what, any system will have a set of characteristics describing that system, right? Whether it is an embedded system or any non-embedded system for that matter. Unlike general purpose computing system, we know that embedded systems possess certain specific characteristics, and these characteristics are unique to each embedded system. So in this video, let us try to find out some important characteristics which will define these embedded system. So the first one is embedded system should be application and domain specific. If we closely observe any embedded system, we will find that each embedded system is designed to perform a set of defined tasks, right? And they are developed in such a manner to do specific functions only. They cannot be used for any other purpose. While discussing or while comparing embedded system and general purpose system, we have discussed about this. So it becomes a major criteria which distinguishes an embedded system from a general purpose computing system. So get a better idea. If I take an example, there are a lot of embedded control units present in microwave oven. Similarly, there are embedded system control units present in air conditioner. So you just imagine interchanging them. Can you have an system control which is designed for an air conditioner sitting in oven, and some system designed for a microwave oven to be placed in air conditioner? Yeah, it is just not imaginable, right? It is beyond imagination. This is not possible. You know that. We know that. That clearly suggests you that an embedded control unit designed for air conditioner is meant for air conditioner, maybe measuring the temperature of the room, which is a control variable, and then switching on or switching off the compressor motor, regulating the speed of the motor. These are the functionalities of a system which is sitting inside AC. But when you come to a microwave oven, there's so many functionalities there. Maybe grilling, right? Only simple heating, different temperature settings. So there are so many controlling there. So this cannot be interchanged. This is true when it comes to domain specific also, because this says domain specific, application and domain specific. It means an embedded control unit developed for a particular domain, say maybe telecom, cannot be replaced with another control unit which is designed to serve another domain like consumer electronics. So it is domain specific also. So this is one of the major criteria, or this is one of the major characteristics. So the next one is reactive and real time. It's very important to understand this characteristic. So what do you mean by a reactive embedded system and what do you mean by a real-time embedded system? So embedded systems are in constant interaction with the real world. For that we have these IO subsystems, maybe through sensors or any other user defined input devices, right? These will be connected to input port of this embedded system. Any changes happening in the real world should be captured by these sensors or input devices in the actual time or in the real time, and this should be fed to a control algorithm which is running inside my embedded system to bring out a controlled output variable. So this is the basic flow of functionality of embedded system. We know that. But what is challenging here is the changes happening in the real world may be periodic or aperiodic, means unpredicted event. We call such changes as event, okay, an event. So the event may be periodic or unpredicted. So if your embedded system is expecting an unpredicted event, then such system should be designed such that it should be scheduled to capture such events without missing them. So we say embedded system should be reactive systems. It should react to the event happening in the environment then and there. That's why I say it should be real time also. It is reactive. Okay, my system is reacting. Nice. There is some event happening. My system is designed to know whether there is some rain outside. Okay, when rain comes, my system is detecting that. Nice. Okay, after detecting what? Okay, for example, you take a system in a car, in a modern car, where you have this auto rain wipers, right? It detects rain and the wiper automatically switch on. So it is reactive. It should be reactive and real time. Your wiper cannot afford to switch on when there is no rain, and your wiper cannot afford to switch on after some time of rain. It should happen at the desired time. So the real-time system should be deterministic, means it should respond to request or task in a known amount of time. That's very important. So a real-time system should not miss any deadlines for task or for given operation. That doesn't mean that all the embedded system should be real-time in operations, not required. I'm telling that this is one of the characteristics what embedded system should process. If it is designed for real-time, it should be a reactive real-time system. A more apt example is flight control systems or anti-lock braking systems in car, right? These systems should respond deterministically then and there. Otherwise it is going to be a mishap. We call it as critical missions. So in such a case, the designing of embedded system should take worst case scenario into consideration. So this becomes a very, very significant characteristic of an embedded system if my system is designed for real-time operations. The next one is real-time embedded, the normal embedded system, real-time or not, embedded system should be able to operate in harsh environment. I designed a system, and on working table, on my table where I am designing the system, it's working perfectly fine. And once I fit this system into the application, I should be knowing where this system is actually going. I should know whether that environment is a high temperature zone, a dusty zone, or an area subjected to vibration, shock. So my embedded system, if it is deployed into such environment, the system should be able to withstand all these adverse operating conditions. So the design should take care of the operating conditions of that area where the system is going to implement. If the system is being deployed in a high temperature zone, then whatever the components if you have used in developing this embedded system should be of high temperature grade, isn't it? It should be able to withstand that amount of temperature. Okay, it is going to be operated in 150 degrees Celsius, 200 degrees Celsius. Okay, my devices should be able to or capable of withstanding that amount of temperature. An embedded system which is designed for applications in automobiles should be able to withstand a good amount of vibration and shock. Right? When your vehicle moves, these systems are subjected to continuous vibrations and shocks. So it should be able to withstand that. When it is some industrial application based embedded system, it should be able to withstand some power supply fluctuations, dusty environment, corrosion kind of. So all these need to be taken into consideration for embedded system which works in harsh environment. So if you have or if you design an embedded system for such environment, then the capability of the system to overcome these harsh environment becomes a characteristic. The next important characteristic I would like to discuss will be distributed behavior of the system. What does it mean is embedded system may be a part of a larger system. It should not be a single unit of system. Okay, I have a system within which I will have 3 to 4 embedded systems. Each one application specific. That is the first characteristic, right? 3 systems within a system where all the 3 are performing different functions, but they should work in tandem. The functionalities of all these 3 systems should be synchronized. For example, if you take an automatic teller machine, that is ATM. So an ATM will contain a card reader which reads your ATM card, right? So a card reader is an embedded unit which is responsible for reading and validating your ATM card. Then you will find a transaction unit, okay, which is basically for performing transaction in the sense to communicate with the external world, with your bank server, whether you have that much amount, whatever amount you have entered, all this. So we call it as transaction unit. Then you have a currency counter unit, okay, which is for dispatching or vending this currency to the authorized person. It's not over that. Okay, then some ATMs have printer units also. Nowadays, for saving trees, we don't use this transaction printing details, right? But still, it is having a printer unit for printing the transaction details. Now, see, all these 4 embedded units need to work together if you want to vend currency from ATM. They are all independent embedded systems, but they work together to achieve a common goal. So my card reader, my transaction unit, my currency counter and my printer unit, all these 4 separate control units should have that distributed characteristic to work as a single system towards a common goal. That's nice. So the next important characteristic is the size and weight. Embedded system should be as small as possible. We believe in the phrase small is beautiful. Agree? So this can be viewed from 2 things. One is when you design the system itself, you have to go through so many criterias and make sure that your system is small enough. based on the application where I am going to fit my this system. It is not necessary that an embedded system unit designed for air conditioner is really tiny, not required. But at the same time, the same control unit which is designed for an automobile should be smaller. It cannot be cumbersome as your home air conditioning system. So it depends, right? So based on the design, you decide the characteristics, means the size. Okay, this is one side of it. The more important side is when this system becomes a product. So aesthetics of a product become an important factor in choosing that product. Everybody will agree. If you want to buy a new smartphone, what you do, you compare, right? You compare so many things. But along with that, you compare the size of the phone as well as the weight of the phone also. The shape of the phone, style of the phone, right? So definitely the product aesthetics will be one of the deciding factor to choose a product. This is because of the convenience to handle, because people are more towards comfort. So you are more convenient to handle a compact device than a bulky product. So in embedded domain also, this compactness is a significant deciding factor. So most of the application demands a small sized and low weight products, making it an important characteristic of all embedded system. The last and very important characteristic would be power management. It's another important factor, okay, that need to be considered in designing embedded system. It's a concern basically. Power is a concern. We should always design the embedded system in such a way that it minimizes the power consumption and thereby heat dissipation in the system. That's because if your system is drawing more power, there would be more heat, I square R losses, heat dissipation. And if high amount of heat is generated in your system, there will be high demand of cooling requirements. You may require a cooling fan or any other technology which will occupy additional space and make the system bulky, which will affect the previous characteristic. I am trying to make the system small and as light as possible, and the next characteristic of the system is a concern now. So we should have this ultra low power components, okay, which are anyway commercially available. We are going to use such systems to produce an embedded unit. So we have to select the design according to the low power components with power saving modes. Remember, power management is also a critical constraint in handheld devices, or we say battery operated devices. More, if the power consumption is more, the battery life will be reduced. So power management becomes one of the major factor or one of the major characteristic of an embedded system. So to summarize, like any other system, embedded system is having lot of characteristics. So I have just shortlisted 6 of them. The first one was application and domain specific. Embedded systems are application specific. A system defined or designed for particular application cannot be used for another application. The embedded system should be deterministic. It should be operating real time and should be responding to required task in known amount of time. The next one is a designed embedded system should be able to operate in harsh environment conditions. Always we will not have controlled environment conditions where we design these systems. So we have to check where this is used, and based on the application we should be able to design the system. So it becomes an important characteristic to be taken care of. And in most of the applications you will have more than one embedded units working in tandem to give you the final goal. So your embedded system should be able to work in a distributed environment, so it becomes a characteristic. And nowadays people are loving the phrase small is beautiful and the aesthetics of the product. So small size and weight becomes an important characteristic. And last but not the least, power management. So power is always a concern in any system. So we have to manage power in almost all critical applications. Power saving or reducing the heat dissipation becomes one of the characteristic. So that's all about characteristic of an embedded system. Thank you for watching.